Hello, this is a project that I worked on Audacity. Well, this project is mainly for it's a classifier for identifying the dog breeds. Well, if this is a the dog breed, like here we have images of dogs in this classifier. It's a beagle, boxer. Well, we can just check the images here. We can open it. This is a boxer. Here we have different type of dogs images, dog images here. It's not actually for dogs. It's for just animals. Like we have dogs, we have cats, we have different things here. Here we have some cat. We have a bear here. So it's not only for dogs, but for animals. Like so. What does this classifier or this project do mainly? Well, this is a supervised classifier, a deep learning model. Well, by meaning a supervised, so when we say supervisor, so we have of course label data. So our label data in this case, the label data is the pet images. In the pet images file, we have the labels on the files. So we have a supervised model here that uses CNN algorithm. We have our database. In this case, it's labeled database. This is our database mainly. It's kind of database. So, and let's explore now our project. What are the files there? What they do? So let's just from the start. Let's start from here. Well, actually, we shouldn't start from here, but from classify. No, from this one. Get input arguments because well let's just start from the first one. Well, so here we have this file adjust results is a dog. So what does this file do? Well, just we will import all these files in the classify images. Here we will import all of these things where sorry, in the check images, sorry. We will import all these files here as functions. Here we have them from this file, which is adjust results for is a dog. We'll import the function which is called adjust results for is a dog. Well, the function name is the same as the file's name. So in this file we have just one function. And what does this function do? So for each file we'll just talk about that. What does the function do, what are the inputs of the functions, and what are the outputs of the function, because that's what matter in general for functions. So for this function, adjust results for is a dog. This function is, well, is it recording? Yeah, it's recording. So this function adjusts the results dictionary. We will just explore the dictionary here, the dictionary that will have some keys and values, and our keys will be the labels data that we will just have from the pet images folder here. And so this one adjusts the results dictionary to determine if classifier correctly classified images as a dog or not as a dog, because here we have images of dogs and some images that are not for dogs. So first our classifier, so I'm sorry, I forgot to talk about what this classifier or this project do. Well, if we have now an image of an animal, so the first task is to identify if this is a dog or this is not a dog. This is our first task. Then we need to identify the breed of this dog. We have many breeds here that we will test. Sorry, first we will train our model on, then we will test to measure the accuracy of our model. We will just work on this thing here later on. We will just check the results. So we have here, this is a Boston. Well, here we have the image, and this is the label of the image, because it's really important in machine learning or just artificial. It's specifically in supervised learning. It's really important to have label data. So this is the label of this image. It is Boston Terrier. So I have to remove the cache memory probably. So anyway, so this is this one, the so for this file, adjust results. What does this function do? Well, it just adjusts the results. So If classified correctly, classified images as a dog or not a dog, especially when not a match. Demonstrates also if model architecture correctly classifies dog images even if it gets dog breed wrong. So our main task here is to classify if this image is for a dog or not for a dog. Not actually, it is specifically for the breed of the dog. So this is the task, the purpose of this function. So what are the inputs of this function? So we have here two inputs. The first one is the results dictionary. We will just talk about later on here. And this results dictionary has keys and values. Any dictionary has keys and value. And the key, our key here is the image file name, which is the label. And the value of this dictionary is actually a list. Okay, so the keys is just a string and the value is a list. And what is this list for? This list will have three indexes. The first index, index 0, is for the pet image label. The second index, which is number 1, will be for the classifier label. And the third one, the second index, will be for the integer. This integer will just be 0 or 1. 0 or 1. If it is 1, so it's a match. This is so this is a match between the file name and the label. If it is if it is 1, it's a match. If it is 0, so there is no match between the label and the file name. Sorry. So we will have also more indexes. We will speak about them later on also. And then we have the dog file here. And the dog file, in this case, just a text file that contains names of all dogs. We have it here, somewhere here. The dog file. We will open it here, so it means that it is somewhere here, the dog names. So we have all the dogs' names in this file here. Well, there is no need to open it. So these are the inputs of this function. This is how it works, and also there is comment that I made and it was just put by Audacity, some of them. And this is the, just doesn't matter how we did this. Well, it's actually explained. It is explained how I did these files because I did all this file on my own. And what are the outputs of this function? Well, it's just return results dictionary. We'll just return our results dictionary here. So this is the purpose of this function, of this file in general. Then we will have this file which is for calculates results stats. Well, actually, let's not speak about this one first. Let's speak about the get input args first, because, well, we should have started with this one actually. So what did this function do? So this function, which is called get input arguments, it retrieves and parses 3 command line arguments provided by us, the user, or whoever. Just put the command on the terminal. They run the program from a terminal window. This function uses Python's argparse model to create and define 3 command line arguments. If the user fails to provide like some or all of the 3 arguments here, which are these, it will just use the default ones. Like if the user didn't just put it this dash dir, which is the directory, sorry, the directory, so it will just use the default one, which is this one. So when the user put well, the command actually is going to be this one, which is check images. We will just use this one later. Well, I didn't here put down anything, like I didn't identify, well, the default directory that our classifier will search for the pet images is this one because we identified here as the default one. And well, what if I don't want to use this one? I want to use a different directory. So all what I have to do now is just to write down like this and put down our directory. Like directory is going to be something like anything. So this is our new directory that we will use instead of this one. So this is the default one, and now we have overridden it. This is for the argpass model that is available on Python page. Argparse. Okay, I wrote it typo. So then we have the second command here, the architecture that we will use. The default one is VGG, but we can use actually the CNN, which is also a deep learning algorithm, also VGG, and there is a third one. There is a third one that we will use later on. And the last thing we have in our arguments, so our just this line consists of 3 arguments in this case: directory, architecture, and the doc file. The file which has all the dog's names is called in this case the dog name. So we can change it also here by like anything we want, dog file, anything also. So in this case we will override the default one, which is dognames.text. And that is all what this function is. And we will just call this function in the check in the check image. Sorry, in the classify images. In the check images folder file. So here we will call this file. Here we will use the default one. We'll call it here. Here we will call this function, and so on. And also the same for the previous one. We'll call it also here, which was for the dust results is doc. We'll pass the results, and we'll pass an argument doc file. In this case, it is going to be the doc file, which we put, which is this one here. And then we have this one. Then we have this calculation results stats. Well, just no, it's actually this one. Let's check this one. Check images. It's better. Well, in this case, we have this. No, it's not this one. Classify images. Let's check this one. This is the classify images folder. This is let's just get inputs, arguments, get bit labels. Well, let's just check this file. It's better. So in this case, the first thing we will do is to import the from OS import less directory. Well, OS is operating system. From the operating system model, we will import a function called less directory, and this will help us, like if we in our system we have this file explorer or finder in MacBook. So we want to import the file names because this is actually a folder on our system, and how we can interact between like how can I just import all these files and manipulate them. We have a Python library called OS operating system that we will use now just to manipulate these files. In this case, we'll just import all these names. We'll just loop through all these files names, and we'll just do some operations on them, like skip this dot and skip everything after this one, and we'll also remove this underscore and remove everything under this just remove this underscore and remove also this numbers. We don't need any numbers here. We'll just to make the labels, like we have a label, and it can be something like this. It can be something also like this, it just makes sense to be like this. So we have this file name. Oh, so what does this function do? Like we've said earlier, just what does this function do? The inputs and the outputs of each function. So this function creates a directory of pit labels based upon the file names that we have of the image files. These pit images labels are just used to check the accuracy of the labels that we have, because our just model will return labels, and we want to know if this label is actually correct or not. So we actually don't know if the computer nailed it and succeeded in defining this thing correctly, so we need to measure the accuracy, because like in supervised learning it's a very important stage to measure the accuracy of our model. So then we have this thing here, and then we have these things. We have this for label, for loops, and this for loops will just for each pit, so we will just took everything from the list directory pit images, just list all the files in the pit images folder and just as a list, and put them here in the file names. So here we have a list right now. Now we want to make a dictionary, empty dictionary, and the results dictionary. We used this dictionary up on the adjust results for isDoc folder. Then add a new key value pairs to dictionary only. So here we have this empty list. So we will loop through all the file names that we got. We will, if pit images 0, if the first if the file name starts with dot, we will skip this file. We don't want to check any file that starts with dot. It's kind of a hidden file, so we don't want to check this one, because any hidden file, any file that starts with dot is actually a hidden file on our system. We can check this on our terminal, but there is no need to check this. And we will also pit images. So we will store each file name in the pit images file variable. We will just lower all the letters here. We don't want any uppercase. We'll just make all the letters in the pit images. We'll just make all the letters lowercase, and split. If there is a underscore, we'll split this thing. We'll split the name into two, like here. We'll split this into Beagle 01125. We'll split it, and also here will be split it two times, 1, 2 times. So it will be basic space HOND space 01034, and then for each word in the pet image, because it will be like a list right now. For each word in the pit image, if word dot is alpha, pit image will just because we want it to be like something like Boston Terrier. It will, this line will just do it like this here. Here we have two words right now, and after we did this, we'll just strip. We will remove this any white space. If there's a space here, we'll just remove it. That's what it will do. Like if we had a space here, just remove the space, white space. We don't need it anymore. And then we will append it to our list, our pit labels list. We will append this new word, this new file name here, because we want to make labels of this data, and so on. Here, like the same thing we will do here again. Just any interesting other folder here, other function. We have this print print file. We just want to make our results to be pretty, so we will just make some functions calls here. We'll just make some just adjustments to make the print look pretty. That's it here. It's not really interesting, but it looks interesting. Of course, when we work on the terminal, it's very useful to work with it. And here we have this VGG uploaded image. No, it's not. We don't want to talk about this one. Anything else? Print. Get pit labels. We've talked about this one. Input arguments. We've talked about this ones. Check classify the images. Oh yes, classify the images. Well, we will actually, first things first, we will import classifier. We will import from the classifier model. We will import the classifier function. Well, and it's for the CNN model that we will use later on. And here we have this classifier. This classifier function accepts two or takes two arguments. The first one is the images directory, which we got from one of the files here. Get pit labels, the argument. No, it's not this one. Where is it? Anyway, and we will have the key and the model that we will use. And the model we can be one of the three models that we will use, either CNN or VGG or the third one. And the key, of course. Then we'll just manipulate these things, and we will just add them here, then we'll check them, and so on. And here are the stats. Well, it's a very complex one. It will take a lot of time to speak about this one, but it's really complex one. Well, it's not really that complex. It's just for the stats. We'll just check everything here. It's better to see it here. This thing. So, well, all these files, all these functions that I've spoken about, we will import them in the check images. This file here, well, they're all imported here. Imported, then we called these functions here. With the arguments, of course, that we got. And we have this print functions, and we'll just this main function, we always do it in the main file that we have. Anyway, let's just skip this one. Let's exit and clear this thing. Now let's just run this file, which is the check images file. Let's just run this file. Let's write down here Python check images. Check images py. Now we'll run this file. It will take just some time because we have many libraries here, so it will take a lot of time just to run all these files and using all these libraries. And anyway, Python is interpreted language, it's not compiled, so it will take much longer time than compiled languages like C. If we use C, it will be much faster, but it's more complex, a lot more complex than here. So let's just talk about this thing that we have here. First, we have this thing. Here we have the file name, and then this file name, like when we talked about the get pit labels, this get pit label function takes this as input and outputs this one. The output of this function is the results dictionary. So the output is the results dictionary. We will just split, remove these numbers, remove this JPEG, and make everything lowercase. We don't want underscore. We want here's a white space. We don't want any white space at the end. So we have only this white space if it is two words, but if it's one word, so we won't have any white space here. So it's Beagle and so on. These are the file name. And then we have this pet image label dictionary. we made this dictionary when I showed it here. This dictionary, like I said, it had the key and it has the value. The key is the file name, and this is the first key. It's labeled very good here. And it has our values here also. The label, Great Dane, Beagle, and so on. Match. So we got here a match. Our classifier nailed it and classified this one. This is the real. This is our label's name. This is the file's name here is Great Dane, and our classifier classified it as Great Dane. Classify the dog as Great Dane. So our this is a match. Our classifier succeeded in predicting the dog's breed, and also he succeeded in this one. He succeeded in all of these. He identified them correctly. Identified all of these things correctly. Our just that's very good results. But our classifier is not perfect. It will also have some mistakes. It will make mistakes because our labels are not really that big. It was just about, I don't know, about maybe 30, 40, 50 images, and that's not enough because usually we have thousands, tens of thousands of images to train our model on. So we need more data. So of course, our model was trained on on more images in the back end, and we're just testing our model on these things, on these images. So our model was actually trained on more images in the back end. And well, and our model failed to identify 5 images. Out of the 40 images here, we got 35 matches. Our classifier succeeded in predicting 35 images and didn't succeed, just failed on detecting 5 images. Well, the classifier detected them, but detected them incorrectly. Like, this is a poodle, but he detected it as a just, I don't know, just as a skunk, whatever. Just, he didn't predicted it correctly. And this is the stats. We got these stats from the statistics. These statistics from the stats folder, the stats file, which is here. We have talked about it briefly. Talked about it. Wait, where is it? Stats. It's somewhere here. Yeah, it is somewhere here. Calculate results stats. This one. So it's really important in machine learning to know the stats and to know how our classifier did. So in the stats here we have 40 images. 30 of them is for 30 of them are for dogs, and 10 of them are not for dogs. So our model succeeded, and we can just see the stats here. It's better to check it from here. So this is the VGG model. We use the VGG model because we have defined it in the check images to use. We have asked it, well, just we passed this argument in the function as VGG. We didn't pass it as CNN, so we used the VGG model algorithm here. So we had 40 images. 30 of them are for dogs, and 10 of them are not for dogs. They are also for pets, animals, but not for dogs. Maybe a rabbit, maybe a cat. Well, it's red in here anyway. And our model succeeded in predicting all the images of dogs successfully. If this is a dog, he say that it's a dog. If it's a cat, he say that nah, this is not a dog. This is a different animal. If this is a rabbit, so he said, no, this is not a dog, this is a different animal, so I will not just predict, so I'll put this as a dog. It's not a dog. If this is a dog, yeah, it's a dog. So all the images that we had here were labeled correctly. So how does our computer, our classifier knows that beagle is a dog? Well, because all the dogs' names are written in this file, so it compares, searches. Well, I predict this one to be a beagle. Then I search here for a beagle. If I find beagle here, so it means that this is a dog. But if I didn't find the word beagle here, so this is not a dog. So this is how our model knows if this is a dog or it's not a dog. And this is the more hard task, is to identify the breed of our dog. This is actually the one that we got lower accuracy on. And the accuracy in this case is 93%. Well, it's not actually that bad, but we want more accuracy. So how to get more accuracy? Well, maybe just manipulating our just things like, well, maybe we can change our algorithm. Instead of VGG, we can use the CNN. Maybe we'll have better results. And also we can, one of the better ways is to train our model on more images. So the more we train our models, our classifier, our model, the more accuracy we will have. And well, of course, this is 100%, so this one also has to be 100%, because if this is not 100, this is also will not be 100. So we have 93% here. So what images our model failed to detect them? What are the breeds that our model failed to predict them as dogs? Well, it was this one, these two things. The first one, the Great Pyrenees. It is actually Great Pyrenees, but our model classified it as Gauvaise. So why? Why it is, the answer is so simple, because of course they are similar. They kinda look the same. So our model didn't succeed to identify it, or identified it incorrectly, because they are similar. They look similar. Well, as a human I can actually also misdetect them also, because they look so similar. So if you want our model to just identify them correctly, we have to train them on more images of these kinds, of these breeds. So it will just um, identify it, label it correctly, whatever. And then we have this beagle, Walker Hound, Walker Foxhound. Well, the beagle also, of course, looks similar to the Walker Hound. That is why it was identified incorrectly. Incorrect results. Oh yeah, that's it. Just to sum up, this is a classifier, like it's written here. This is a classifier for identifying the dog breeds. Well, it first classifies this animal, if it is a dog or not a dog. Then it identifies the breed of this dog to be whatever it is. And then we have the stats, which are really important for any developer to see these stats, and then manipulates the variables of the model to make this stats better, because we want better stats, we want better accuracy, of course. And that's it. Thank you.